Yeah, my screen is visible.
Yes, sir, it is visible.
Okay, fine. We'll see the last topic of this unit. We'll see working of genetic algorithms. That is, I taken one example. I think same example I will take for the next units also, so that it is easy to compare you. Or any other example also you can take. No issue in that. So only here is we need to solve the problem using genetic algorithm. That is only our intention here. The next unit will go for as a D, differential evaluation, all these things, PSO. So all these algorithms we can use our sphere function. This is the sphere function. That function is standard test function. We can take it any number of variables as well, because here if I mention n is equal to, when I is equal to 4, that means x1 square plus x2 square plus x3 square, and so on up to 4. But for uh, manual calculation purpose, in the programming part you can do any number, but manual, if I take more than more values, then it is difficult to solve our problem manually. That's why I taken x1 square plus x2 square is your function. Now in that, you can notice x1 and x2 are the variables. If this is, I mean, one logic is you can able to understand, so that it is easy for you for the next algorithms as well. It is more or less similar. Now, we can observe the thing x1, x2 we need to find to get f of x is a minimum. That's only the final goal. If it is a maximization problem, you need to select x1, x2 such a way that the function must be maximum. That is the logic. Now, this is the step one. Before starting, we need to fix some parameters. Let it be as a population size. Again, same. In programming part, you can give maximum population size. Let it be it is a 50 or 100 or 25, anything. But for manual calculation, to understand the logic, I have taken population size is 4. NP is equal to 4. And then number of iterations are 10. And now I will explain only one iteration, so that same thing will repeat if you use the function while function, if iteration less than or equal to 10, uh, like that. Once it reached the number of iterations, we can go for as a termination criteria. And here, the bit size, we can see that bit length taken as a 4. That is one point. Depends on your input and output parameters. You can change that bit size also. Means, if control range is very high, then you can go for as a more bit size to reach the maximum value. Now, I mentioned morning class also. There is a probability of crossover and probability of mutation. This will decide based on the parameters population you have taken. So let it be in general. Probability of crossover is zero point 0.8. Probability of mutation is 0.3. I have taken just like that. You can take some other value also, but preferably probability of crossover will be the maximum or more, and the probability of mutation will be less. This is the thing. Now, what we can do is, first step, we are fixing these parameters. The next step, randomly generate the binary solution. So now, 4-bit dimension. No, so it is very easy to understand. You can see step by step. Now, 4-bit, how many variables? X1, X2. So first we have to generate X1 variable. These are the population. How many population? 4 populations. 1, 2, 3, 4 population. This is randomly within the limits 0 to 30. You can take it as a 4 populations. In that first population x1 and x2 both you have to write. This is the x1 and x2. So total is a one solution, and all together we have as a 4 populations. So one population, let it be 1 0 0 1 1 1 0 0. This is the x1 and x2 population variables. For x1 and x2, I represented as a binary coded. Then there is no rule you need to take same only 4 population 4 bit for x2 and x1. Same is not required. Suppose here in the mention in the problem x1 x2 both limits are mentioned 0 to 30 only, but some other problem x1 limit may be 0 to 30, x2 limit may be 0 to 80, let us assume that. Then 4 bit is not possible. You have to extend this bit randomly for x2 alone. That's what unequal bit also is possible. Now, what I did, population vector created. For this is only random population. So we have taken 4 populations. Then what next? We have to decode this. There is 1001. What is x1 now? As I mentioned, the value 1001 means what I can write 1 into 2 power 0, 0 into 2 power 1, then 0 into 2 power 1, then 1 into 2 power, 0 1, here 2 power 2, here 2 power 3. Then what is your answer? 1 into 2 power 0 is 2 power 0 is 1. These two are zeros, and 2 cube 8. That means total is 9. So this variable value is 9. I wrote like this. Similarly here, how to calculate that value? I already explained in the introduction and procedure of GA encoding. Then what you call it as crossover, mutation operation, selection operation. All these things I already mentioned. But now again see how we will get the 12 here. And this is 2 power 0, 2 power 1, then 2 power 2, that is 4, 2 power 3, 8, 8 plus 4, 12. Like that, for all the populations, we need to calculate for third one, fourth one, like that. This is the first, second, third, fourth. Now what you know is, I know at this point, what is the value of x1 and x2. Once I know x1 and x2, these are the variables. You put it into function. So what is the function value? X1 square plus x2 square. That will be as a function value. So now we can mention it 9 square plus 24 square. That will give as a 900. This is the function value. And now similarly, there is another variable 3 square plus 7 square. That will be as a this. So like that PD decoded value, and then I'm squaring here, because while I'm squaring you can observe here the one more step is missing here. You can see this is the decoded value. So we are calculating the x value in terms of using this formula, x minimum plus maximum minus minimum by 2 power n minus 1 into decoded value. So these are the decoded value. So this one is a decoded value. Now the actual value will be getting x minimum is what? 0, and plus x maximum is 30 minus 0 divided by 2 power n. N is 4, then 2 power 4 minus 1 into decoded value. What is decoded value? This one 9, 12, 3, 7, 4, 5, 6, 10. This we are decoding from the binary. Once if we get this, then 30 by this value 2 power 4 minus 1. then 2 into decoded value, we got it. And simply, we'll get the actual value. PA is the actual value, PD is the decoded value, this is a population. Now we got this 2 into decoded value. So 2 into 9, then 12 into 2, similarly 2 into 3, 2 into 7, 4 into like this. So we'll get it as a decoded value. From the decoded, we'll get the actual value. Now this 18 square plus 24 square, that will give 900. Similarly, 6 square plus 14 square, that will be 2. Like that, we'll get the function value. Now, this is the one, these things will further and further also. What we can understood from this, there is a set values, whatever the population, then total number of iterations, then PC, PM, all these things will get it as a population constants, something bit length you can define, crossover probability, mutation probability, then total number of iterations, and then population, all these things. From that, second step is simply random generation and decoding actual value and function value. That is the second step. So these all ones, zeros, all these things is you can pick up 4-bit, but wherever you want to put 0 or wherever you want to put 1, all these things you can put it randomly within the limits. What is limits here? Limits are 0 to 30. Within the limits, anything you can write it. Then you have to de- decode. So decoded, already I mentioned how to calculate the decoded. Order will be 2 power 0, 2 power 1, 2 power 2, 2 power 3. If you have further and further, you can get 2 power something. So that is the decoded value. Once if you get the decoded value and you have to make it as an actual value. How we can get the actual value? Using this formula. What is this formula? X actual value is equal to X minimum plus X maximum minus X minimum by 2 power n. 1 minute. Hello. Now we can see here that is the first bit we can able to get like this. Now, which one is better solution? You can easily identify because our problem is a minimization problem, which is having as a minimum value, that is a best solution. Let it be third chromosome is a best solution. Just telling like this to understand. At this moment, best solution is a third chromosome. So x1 value is 8, x2 value is 10. Then we'll get it as a minimum function value is a best solution. And similarly, we can observe next step. What is the first step? Simply you generate the random and then you have to give it to the function. We'll get it as a, what is the function values. Then we'll go for second step, means in the next step, random candidates for tournament selection. So why this tournament selection? Second step always see initialization, then random population, then selection, then crossover, then mutation, then termination, final step. These are the sequence. So in that, we can see that select the two random candidates for a tournament. So what are the random candidate from the actual values? So what are the actual values? These are the actual values. In that randomly you can select the two solutions to compare, because tournament selection is always what we are comparing two things, and which one is the minimum that is selected, because the function is a minimization. Suppose function is maximization, then which one is the maximum? We can easily select maximum value is final. So in that case, what I did is I selected two variables. Let it be randomly I selected second population. Another one they have selected 12 and 20. So that means this. So second one and fourth one is selected randomly. So now the tournament selection are two parents randomly pick up. 6 and 14 is a one solution. Another solution is 12 and 20 is a another solution. Corresponding function value is 232, and this corresponding function value is 544. And which one is the minimum? This is the minimum, because our function is a minimization problem. Therefore, I can make it 232 is your meeting pool. So this will be selected. Again, you take some two. Remaining two is what? 18, 24, and then 8, 10. For this function value is 900, and this function value is 164. Which one is the best solution? 164 is the best. Like that. That is what the tournament selection. Two random candidates for tournament selection, we can able to observe these values. Which one is the minimum that will be selected? So you write all the four here. Suppose if you selected tournament is conducted between P2 and P4. Which one will go to meeting pool? P2, P4 in that 232 and 544, which is minimum 232. So P2 is going to meeting pool. Now we'll see this P1, P3 is remaining. This is 900, this is 164. This will go to meeting pool. So like that, randomly you have to select, and we will go for as a name again randomly, because why we need to do this many? Because four populations are required. In that four populations, we selected two by selecting these two parents related with these two populations. Again, randomly you select two more. Then P1 and P4 in this case. The P1 is 900, P4 is 544. In that one will go for meeting pool. And another random selection, 232, 164. Again, so what is meaning here? P3 is selecting twice also. The reason behind this, which is the best solution, they have chances to select more than one time. So that is what the tournament selection is going to be. Now we can observe this is what from the previous step only all these data. We are selecting the two candidate and we are performing the tournament selection. One will win, that will go to the meeting pool, which is the minimum that will go to the meeting pool. In this case, this will be in this case, this will be now meeting pool, four populations are there. Now, that is all about the step three tournament selection performance, and compare the fitnesses while you are, which is the minimum fitness value will be selected for the next uh, iteration or next step, we can say. Now, with that, we got it. Then after four tournaments, best solution has two copies, worst solution has a zero copies, like that. Now we can notice any case, this all four, worst is 900. Check it. How many times it is performing with any other team, but this worst person will not selected for the meeting pool. That's what the intention of this step. What we are doing, best solution has two copies, host solution has zero copies. According to this function, you can see which one is the worst. 900 is the maximum value, but our function value is a minimum. Minimum function problem. You have to select 900 is the worst now. In that case, that will not select for the meeting pool. Now, this step also over. What is the next step? To go for a crossover operation. I already explained how to perform the crossover operation. Again, same problem. You select randomly two parents, perform the crossover operation, and will get it as a two offspring. Two parents, two offspring. No, I selected as a parent one and parent two. First two I have taken randomly. Let it be as a 1 0 0 1 1 0 1 1 1. This is consisting of x1, x2, both will be there. This is a parent one, this is a parent two. As per our first step constant, probability of crossover is 0.8 we have taken. Now what we can do is, probability of crossover is 0.8. Estimate. In that, what we can do is, randomly you generate one number, because it is very important question. You just understand how to solve the problem with one example I have taken. You can take your any example or exam also. They will ask, instead of x1 square plus x2 square, they may given 2x2 plus 3x3 like that. Or let it be 2x1 plus 2x3 x2, or more variables also, or square or root or anything, just only function that is replaced with this value. Instead of x1 square plus x2 square, they may give another equation. You can substitute this data into that. That is the different version. Now, we'll go for crossover operation. Two parents we have selected randomly, and you generate one random number. What is that random number? You are generating one random number 0 to 1. It may be 0.1 or 0.2 or 0.32 or 0.45, anything. So now you have to compare this perform the crossover. While you are performing, random number is less than crossover probability, then we'll go for as a crossover operation. Otherwise, you don't do any crossover operation. Is it clear? Random number is less than probability of crossover value, then you have to perform the crossover. So what is that? You can see I have taken, let r is equal to 0.2. Probability crossover in the first step, I think 0.8 we selected, and point 2 less than 0.8. Condition is satisfied. Then you will perform the crossover. While you are performing the crossover, we have a lot of methods. One method is 1 bit crossover or 2 bit crossover, like that. So now in 1 bit cross, just for understanding, I have taken as a 1 bit crossover. What is 1 bit crossover? Randomly you pick up the which bit you to select. Let it be 3. You can write one line like this. Third bit. This is a 3. Then remaining portion will exchange this. This portion will go here, and that will be as offspring 1. This will come down. This will be as offspring 2. Now we can see that while we are performing the crossover, whether we want to perform or not, that will decide by this condition. Randomly I taken R is 0.2. PC is already selected in the first step is 0.8. If this condition is true, then perform the crossover. While you are performing crossover site, you have to select whether 2 or 3 or 4, because it is total how many bits are there. Here is 4 bits and here is for total 8 bits are there. So randomly, any one of the site you can select. Now in this problem, it is always will change. So let it be randomly. A number is generated between 1 to 8. There is a number got it as a 3. Now you put the crossover and perform the crossover offspring 1, offspring 2. Like that, you have to do crossover operation. Now you can see, randomly select another pair. First these two parent 1, parent 2, then parent 3, parent 4 you can select. Again, what is the condition? Perform the crossover. For that, what is required? You need PC is 0.8 already, and you generate one R. Let it be R is 0.6 and PC is 0.8. So PC is more. So more probability of crossover. That we have to go for crossover. What next? Crossover site we need to generate randomly. Earlier crossover site is mentioned as a 3, but now you can make it as a 4. Just it is a random number, no, it is always varies. The problem is not fixed. Even two students are doing the problem, the answer should not be the same because it is all random number. No, suppose in your case, one student got zero point 0.8, you are going for crossover operation between these two, but some other student got zero point 0.9 and our probability of crossover is zero point 0.8. Now your random number is zero point 0.9, so crossover will not perform for these two parents like that. Then answer will differ, no, with first student and second student. No, that is the way we can able to select the crossover operation. Just a minute. Mm. Now we can see here there is a probability is going to change. Select the random crossover site r is equal to 5. If we select, then what will happen after 5 digits? Can see this is first, second, third, fourth, fifth. Here we make it as a 5, and the remaining portion will interchange, swap. So therefore offspring 3, offspring 4, we got it like that. We can able to do the crossover operation. Now we performed the crossover operation. Now what are the offspring? One total we got mm, 4 offspring. This is offspring 1, offspring 2, offspring 3, and offspring 4. So once if we get all 4 offsprings, then bitwise mutation we have to do. Next step is mutation. Once the crossover is over, then we have to go for as a mutation. Mutation also we have the different methods. At moment to understand, we'll take it as a bitwise crossover operation. Bitwise means just you can swap one number. We will see that. For that, same like probability of crossover, we have zero point 0.8. No? Similarly, in this case, probability of mutation taken as a zero point 0.3. Let it be Pm is equal to zero point 0.3. Now, for offspring 1, because these are all offsprings, we already get it from after crossover. Now we got all crossover, 4 offsprings we have. First offsprings I have taken. This is the first offspring. And then select random number to check if the mutation is to be performed or not. How we can do? Just for all which bit we want to do the mutation. For that, you select one R value, that many bits from 0 to 1. Suppose for this we got zero point 0.6 random. This is a system will generate automatically. Even calci also, if you put rand, it will give the different numbers like that. So now what we need to do is PM in this case is zero point 0.3, and R value is less than PM. For those values, we need to perform the mutation. Now R values, how many values? Earlier, we selected only one R value, whether we have to go for crossover or not. But now here is a bitwise mutation. Each bit will generate as a one random number and compare this check R less than PR. Now, first case, you can see R is zero point 0.6. So, zero point 0.6 less than zero point 0.3. So, it is fail. So, we no need to do mutation for first bit. Second bit 0.1 less than zero point 0.3. So it is true. Then you have to perform the mutation. So this is one thing. All other parameters you can see this is zero point 0.5, no need mutation, and less than zero point 0.3 only we have to perform the mutation. So R value is less than zero point 0.3, and then only we have to perform the mutation. Only one case we are raised, that case we have to perform the mutation. What is mutation in that bit? Suppose in this bit is we are performing because the bit value is 0, then after mutation, that value will become 1. Or else, if any other case, this value may be 1, then after mutation, that value will become 0. If 1 is available, we'll make it to 0, or 0 is available, make it to 1. So, like that, we can do the mutation operation. Now we got the offspring 1 mutation. Then what is offspring 2 mutation? Again, you take this. Let it be, I will explain here. Same, you have to repeat for all the cases. Offspring 2, let it be offspring 2. What are the values are available? 0, 1, 0, 1, 0, 1, 1, 1. Then you generate randomly. Suppose some values. So now also I'm doing some random value. Let it be as a zero point 0.8, zero point 0.1, zero point 0.2, then zero point 0.4, zero point 0.5, zero point 0.6, zero point 0.7, zero point 0.8, like this. You got the R value. To which bit I need to perform the mutation. Here, 0.3 is the probability of mutation. Less than zero point 0.3, wherever it is there, for that bits you need to perform the mutation. Now here you can see this bit and this bit. So what is the after mutation? Now I can write offspring after mutation, the values. Here 0 remains. What is here? I'm doing the mutation. 1 is there. Now we make it to 0. And this bit I need to do mutation. Already 0. So we have to make it to 1. The remaining as usual. What is the after 3 remaining 1, 0, 1, 1, 1. So this is the way we have to do the mutation for offspring 2. Similarly for offspring 3, offspring 4, like that you can do mutation. That's what I'm showing. After doing all this mutation, in this case, you can see where only less value, but in the third case or fourth case, all values are greater than zero point 0.3. So we'll take it as such value is the after mutation. So wherever the R value is less than the probability of mutation for that bit, we need to change. If it is 1 is there, you make it to 0, or 0 is there, you make it to 1. This is the performance of the mutation. So now we have all the mutation values. Now it is start from the original problem. Like what we taken the first step there, the random population we have taken. No? After performing the crossover and mutation, now the population is this one. After performing the crossover and mutation, we got this population. For this, again, you have to repeat same step. What you have to do from this, we have to go for as a P decoded value, then actual value, then function value. How we can do this one is a decoded value. How for this 2 power 0, 0 into 2 power 0, 1 into 2 power 1, and then 1 into 2 power 2, then this will be as a 6 matrix. Then decoded value 6 for this 1, and then 2 power 1, 2 power 2, 4. This will be 5. 6, 5 is the first population decoded. What is actual value? You can substitute this formula. Again, 12 and 10. This will be the actual value. Once if we get the actual value, we can substitute this. So now we can observe the result. This is the function value after crossover operation and mutation operation. Earlier, before this, after random generation, from that, you can notice that these function values may be 900 and something you can check it here. What is this value? Yeah, 900, 232, 164, 544. So now that modified to 244, 200, 640, 80. Now, which is the minimum function value? This one means fourth chromosome, a fourth solution will be the better solution. Earlier, I think 163, that number, yeah, 164, third chromosome is better earlier, but now fourth one is better. So after that, this problem is not ended. What we did so far, random, then crossover, then mutation. Then this process has to be repeated in the inside steps further up to a maximum number of iterations. Now we have to go for as a next one is the you have to combine all the solutions. What are the solution? What you call it as the random solution, then offspring solution. What is offspring solution after crossover and mutation? Whatever you are getting, that is the offspring solution. So what we can do is here, this first four will be as a population solution. The last four is offspring solution. From this eight, I need to pick up only four. Which one is the better? Because sometimes the random solutions may be better. Sometimes after crossover mutation solutions may be better. So in that case, I'm going to pick up only four solutions. Now we can see first one is 900. It is a highest value. We don't want to take. From the least values onwards, you have to take it. So now first, which one is the? I need to take four only. No, out of eight. Why out of eight? First, random population we have four values. After crossover and mutation, we have four values. So total eight values. I have to pick up only four because our population size is taken as a four. Now, which is the minimum 80? This is the first value. After that, 164 second value, 200, 234 is 4. And these 4 you can pick up. X2 pick up as a 4 and then corresponding value. So at this point, population for the next iteration, this will be the starting point. Like how we started the problem with random population, how we performed the all the steps. Now this is the starting point for the next iteration. Again, what you have to do, you can do a crossover and mutation. In tournament selection, crossover mutation, all these things will perform and again we'll get it as a now it will become as a starting solution first four and after offsprings we'll get another four we'll pick up again only four and repeat this process continuously the end of the problem. So now we can see that same steps I explained the pseudocode also and flowchart also I already given what you call it as this is a genetic algorithm flowchart. Now we can see step by step first input fitness function, lower limit. You can see the fitness function value is required x1 square plus x2 square. That is a function. Lower limit, lower bound, upper bound. Lower bound in this problem is 0. Upper bound is a 30 dimension and the number of populations, number of iterations, bit size, probability of crossover, probability of mutation. This is a tournament selection. Whether with we are to perform the tournament with two teams or three teams like that, which one only one team will win. That is initial. Then random population P matrix we have to generate. After P matrix, we have to go for as evaluation. Then how many times it has to be repeat the loop number of iteration. That's what we can mention. T is a number of iteration. So perform the tournament selection. Options are four. Suppose only we have to do the tournament selection 2-2. Only one will win. That's why NP by 2. Then randomly choose two parents and check this are less than PC or not. If it is yes, then go for as a selection process and repeat the if not the copy as such value, and this will be repeated for the tournament selection. After that we will go for generation of D, random number between 0 to 1 for mutation purpose. Bitwise mutation you can do. That process will complete in this loop. This process is what you call it as crossover process. This will be mutation process, and then we can add all solutions, and we select only the best solution, best four. Instead of four, you can mention as a population. So in the some other problem, if you take five population, 5 plus 5, 10 will get. In that five you can pick up like that. And this is the pseudo code for the crossover as well as the uh, mutation, and total pseudo code for genetic algorithm. And if you remember this, you can easily solve your problem. In that case, I can see each step. This is generation and then survival of the fitness. Once that 4 bits we are getting like this is the step. Once if we are getting the all from the second step onwards, it will repeat. So this is a pseudocode. Same we can consider for the what you call it as real coded also. Before that, you can see the drawbacks. What is the drawback? Binary GA make the search space is discrete because only ones and zeros like that, and they are unable to achieve any attribute precision. I means if n bits are used represent a decision variable, then 2 power n different values are possible between lower and upper bound variable. To increase the precision, n has to be increased, and increase n results in the large dimension and population size. Having cliff, you can see the transition to neighboring solution in a real space need change multiple bits. So anyhow, this number of bits is going to be vary. Bit size may be 5 or 6 or 7. That depends upon maximum value, because the problem x1 square plus x2 square that is equal to f of x function. X1 may be given 0 to 10, and x2 may be something maybe 10 to 200 also may be there. Accordingly, you have to select as a bit size. So these are the drawbacks in this problem. Now we can see it is simple rather than one step we can miss here. What we can do is decoded value is not required, because directly numerical values we are using, we are not taking as a what we call it as a 0 bit 1 bit like that. We can get it as a decoded value, and that is the reason we can see the encoding of real variables to binary is not required, because what we are doing binary bit to real values is not required, because we are taking directly as a real value. Decision variables can be directly used to compute objective function, because whatever variables you are taking x1 and x2, suppose function x1 square plus x2 square, what we'll do in the earlier, suppose 1001, suppose 5 bits or 4 bits if you take, then it may be, let assume that like this. This is our first population. What we have to do, we have to convert it into something values here. That value you have to put it into function. But now in this real coded genetic algorithm, directly we'll take it as a x1 value, x2 value, mm, like this population. From this, we can directly calculate the function 2 square plus 3 square, 4 square plus 5 square, or 6 square plus 7 square, like that. We'll get it as a all the real values. So this is the crossover site you can select. And directly, if it is crossover site is 3, and this you can keep it and you can interchange this, or this side also you can interchange. Some books they represent it like that also. Anything, we can do the crossover site, and modification in the variables operation is required to explore the search space. Now you can the simulated binary crossover, because we are using as a one more possible option also is available in this case. For the fundamental case, whatever I explained, that is sufficient. But if you go for as a binary crossover operation, while we are performing the crossover operation, we can use this formula. Based on that, we'll generate the offspring 1 and offspring 2. There is a again same parent 1, parent 2 will take it. And then what I did for crossover, will there is a formula there. I mean, probability of crossover and random value are checking or less than probability of crossover. If it is performed, we can do the crossover, whether we can select as a 3-bit, I mean, site 3 or site 5. From there you want to do crossover like that. But there is another formula also available. For you just take it as a two parents to generate two offsprings. Then you can use this formula, beta value, and substitute the beta value here, and we'll get it as a offspring 1 and offspring 2. Use this formula to generate offspring 1 and offspring 2, or directly whatever I explained earlier, that is also you can take it. And a simulated binary crossover, only I'm explaining crossover just for example. Offspring 1 and offspring 2, if pa2 pa is 2 and pb is 8, and you substitute this formula, we'll get offspring 1 and offspring 2. Later some other values you can take it 4 and 5, then offspring values will be like this same. Whatever I use formula, that formula I substitute it as a offspring 1 and offspring 2. So now this is the modified crossover operations. Earlier we can do that is a basic model. Later on, the researchers they find further improvement in the genetic algorithm. If we can do this binary simulated binary crossover operator, then we can able that also one of the example I explained, different kinds of crossover operators. You can use this crossover operator to generate as a offspring. Only different is this formula you have to substitute to get it as a offsprings. Now, impact of that varying the beta, because that parameter is there. So what will happen? The solutions will get faster, or convergence will be faster. That's what we mentioned here. If beta less than 1, and then offsprings are closer, and beta is equal to 1. Offspring parameters are identical, and beta is greater than 1, then offsprings are far apart. So you can see that these offspring distances are very more, and offsprings are very close. Beta is less than 1. So based on that observations, these are all we can do. Suppose if you do the project using this, we can change the beta value and show the results with the different comparisons, and then which value of which range of beta may be good, or like that also you can conclude in the analysis part. And similarly, polynomial mutation. There is a another mutation is available here. Mutation is performed with low probability. Compute delta, and after knowing the delta, if R is less than zero point 0.5, use this formula, and R is greater than zero point 0.5, use this formula, because based on the R only we are perform the mutation. So wherever that lower than the mutation probability, we are using the R value. If 1 is available, you replace to 0, or 0 is available, replace to 1. That is what we do. But here there is a polynomial mutation is another method to get as a mutation operations. Now you can use this formula and get as a polynomial mutation. Again, only offspring how we are going to generate for mutation purpose. And similarly, you can see working example. What is the difference of previous problem and this problem? Exactly same problem. There is a binary coded genetic algorithm. Now we are using as a real coded genetic algorithm. Difference between binary coded and real coded genetic algorithm. We can see that there is a values. So here I can take more variables because now it is a real number. Only one number will be there. I can take any number of variables. But if it is a binary coded, each x1 we have as a 4 bit 1 0 1 0 like that, or 5 bit sometimes depends. And suppose x2 again 0 1 0 1 something, or x3 1 1 1 0, x4 0 0 0 1, or anything randomly. So now all this thing in only one solution, one row. I have to write like this: 0 1 0 1 1 1 0 0 0 0 1. So similarly, next row, third row. So to solve this many x1 variable, x2 variable, x3 variable, x4 variable like that, it is a complicated. That's why in the example I have taken only x1 and x2 variables and solved. But now it is a real coded genetic algorithm. We can take it as a more number of variables also. X1 to x4 I can take, and randomly I have to pick up these values, but the limits will be there. X1 limit and x2 limit or x3, x4 limits 0 to 10 they have taken. Between 0 to 10 only all values will be filled up because random number will need to generate only 0 to 10. So now like that figure. Now it is easy. One step is missing here. Directly can substitute here. So I will get the 84 square plus 0 square plus 0 square plus 8 square. That will be as a 80. For next solution, 3 square plus 1 square plus 9 square plus 7 square. That will be as 140. Like that, we can do directly second step. Randomly generate this population, substitute it into function. Once if you substitute the function, we'll get it as a all the function values. Now, which is the minimum? The minimum value is here 35 is the minimum. As of now, the third population is a best population. And then what we can do as per the second step, as what we did for the previous problem, what you can do tournament selection. Let preferably always will take it as a k is equal to 2. Randomly you pick up the two you know population and perform the tournament selection. While we are performing tournament selection, which is having the minimum value, that will go for as a mating pool. Now randomly I selected as a P2 and P3. The corresponding function value is 140 and 35, which is minimum 35. So the P3 will go to mating pool. And again, another random selection, you can take it 4 and 6, which is minimum 6 is minimum. This will go to meeting pool. And another selection 80 and 113. So P1 will be meeting pool. And similarly, another selection here is 1 or 2 is minimum. That will be meeting pool. This will be P3 and this will be P1. Like that, we can easily generate the meeting pools. So once if we get how many again, 1, 2, 3, 4, 5, 6, because population how many are taken, total populations are taken as a 6. That's why we are getting as a 6 populations in the meeting pool. But we can notice that which is having the highest will not go to meeting pool because our function is minimum, which is having as a minimum value that may be selected in the meeting pool. 35 is a minimum that is occurred in the 2 times. So like that, and another minimum maybe you can see 80 that is also occurred in 2 times. So like that, minimum values will occur in the 2 times or best values in terms of best. But some other problem different is same problem if they ask what you call it as a maximization problem. Maximization of f of x is equal to x1 square plus x2 square plus x3 square plus x4 square. In that case, which one is the best solution? Only problem here, these values will not be in the meeting pool, which is highest, that you will go to meeting pool. So 35, 140 compare, who will win, who is having a maximum value. So P2 is in the meeting pool. And here instead of P6, you can go for as a P4 is meeting pool, and this P5 is the meeting pool, and here 80 and 99 P6 is the meeting pool, and 35 and 113 P5 is the meeting pool, and 140 P2 is the meeting pool. So like that, these values you can put it into meeting pool, and that you can perform if it is maximization problem. And what next step you have to go for as a crossover operation. For crossover operation, I mentioned this method, the procedure for SBX. That is the simulated binary crossover operator. In that, I already shown this problem. You can find the crossover 1 and crossover 2. Again, you can go for crossover 3 and crossover 4. Using these conditions, we can you find the beta and put that beta here. We'll get the offspring 1 and offspring 2. Another offspring 3, offspring 4. We'll get the offsprings. So that's what the crossover example same. You can see the parent one we selected, parent three. Randomly we are pick up this and then let R is selected. If R is less than PC, PC is 0.8, and then perform the crossover. While we are performing the crossover, you have to use this formula. So now U is equal to 0.2, zero point 0.6, something random number, and U is less than 0.5. You have to use this formula. U is greater than zero point 0.5. You can use this formula to calculate the beta. Once you are calculating beta here, that beta you'll using that formulas only we are get the beta. Once you know the beta and put that beta into this formula, because that formula is already mentioned here, and we'll get it as a what you call it as crossover operations. So here we'll get the offspring 1 and offspring 2, like that 5 and 6. In the earlier problem, we got 1 and 2. So now we got the offspring after crossover. Now we'll go for as a mutation. Procedure for polynomial mutation we are using. Using this polynomial mutation, we can easily perform the mutation operations. Now again, offspring 1 I taken. Whether we have to go for as a, yeah, this one is the mutation, and whether you have to go for mutation operation or not, you can check if the delta is there and put it here. This equation, we got the delta value and these are the delta, and now the delta and substituted in this function, we will get it as a offsprings. So now once if we clear crossover and mutation, that solution you mix with the random population solution. Now you can see offsprings, then we got this mutation. Finally, offsprings are this. Corresponding function values are this for offsprings. So we'll get this 0.18 square plus 2.34 plus 0.57 square plus 5.34. That will be as offspring. And now this we are getting as a 34.21, like this. So now what we can do is already random population solutions are there. You mix all the things one matrix, and this is the random. After crossover and mutation, then pick up the only best six, because population size is taken as six. So best six among these things and repeat the procedure. That's it. Now we mixed all the things and we selected as a best solutions. We are combining all these things, and you have to select the best solution and repeat the procedure. So now like that, if we do, we can observe this. If I take number of iterations are 50, initial minimum value is 35 and go on decreasing, and with the different iteration, finally it reaches very low minimum because our function value is minimization. So now we'll get it as after some iteration selected as after 40 or 45 iteration, we reached as a very low value of the function. Like, yeah, this is the procedure we are doing. Now, same thing, pseudocode, all the steps are same. Only problem is here crossover and mutation operation formulas are different here. Instead of bit mutation or single point mutation. They have given as a different types of mutation operation as well as the crossover operators for solving this problem. Real coded genetic algorithm. It is very convenient rather than the binary coded genetic algorithm. So now that's what the comparison also. Binary coded genetic algorithm and then real coded genetic algorithm. BGA and RGA pseudocodes are mentioned separately. In exam, they may ask any problem, whether it is a real coded genetic algorithm or binary coded genetic algorithm. They may ask you to write the pseudocode for this. Means pseudocode or flowchart, both are same. Just step sequence of steps what we can able to do with the problem. This is the comparison of technical with different algorithms, convergence case, parameters case, generation of solutions or best solution. All these methods will be covered. Only GA will be covered. Then the next unit PSO, then DE. Like this, we have some other. You can able to solve your teaching learning based algorithm or ABC algorithm. Once you were aware of any of the algorithm, you can able to solve by your own. You can apply teaching learning based algorithm or artificial bee colony algorithm or cuckoo search algorithm like this. You can pick up any of the algorithm, same problem, you can solve it and compare the results. That is only our comparison or results and analysis part. You can go for as a conference paper submissions, all these things. Only thing is you have to understand the algorithm sequence and how to perform that algorithm with test functions. After that, you take it as instead of the test function, you take it our real problem in our power system problem function. Suppose instead of f of x is equal to x1 square plus x2 square and so on, you can replace that will be f of x is equal to a pga square plus ba pga plus ca for economic load dispatch and all. We can able to solve that. Like that, you can do your mini projects or something to understand these concepts. Or you can go for as machine learning algorithms, where mixture of this and that. You can only thing is you have to do the literature and get that appropriate reference papers, and you take that is a base and you can extend your work like this. So this about the second unit. If you have any doubt, you can ask me, and we'll start on third unit in the next class. So this all about. If you have any doubt, you can ask me, and try to select your guides and submit willingness form, guide willingness form and all, and we'll do your literature. And after that, you can select your paper, reference paper, and then submit the abstract and do the your mini project. Start doing mini project, and then presentations will be there at the end of the semesters. That's all about mini project also. Now, if you need any clarification, you ask me. Otherwise, you can leave.
Sir, another subject is not started, sir, not it. Power converters.
Yeah, only one subject, no?
Yeah, sir, only one.
Power converter. Now I will call to him and yeah, already informed, but I will start. So he may take tomorrow also. I will instruct him to take extra classes, all these things.
Okay, sir.
Okay, thank you.
Thank you.